Okay, here's Springs question number 3, an even trickier one than Springs question number 2. Hopefully you already looked at that video. So again, similar situation. Again, you can define your 0 anywhere you like. Let's see what happens if we take it there, which equals 0. This one gets a bit trickier. Again, what I'm saying is, how would we get this little baby to bounce up and down with the oscillations equal to D, and then figure out a formula for V? Well, as in the past video, we go, oh, well, if we bounce it from that point, it's going to do those oscillations. This full distance here is x, and this distance is d. So total energy at that point where we start the bounce is not going to change just because it goes through the middle. But when it goes through the middle, the actual energy it's going to have is going to be equal to, so the only energy it's got if we define the middle as h equals 0, then at the middle it's going to have an energy of half kx squared elastic energy in the spring. So what we can basically say is that the energy it starts with, and that energy is going to be mgd, and how much energy has it got elastically if it starts at that point? Well, it's got 1/2 k minus d squared, alright, and that is just the energy of being stretched to that point, right? So it's x, or sorry, did I write k minus d? I mean x minus d. X minus d is this distance, so the elastic potential it's got at that point. So what I've written here, mgd plus half x minus d squared, that's the total energy of the system, and that's not going to change. So when it gets to the middle and it's got half kx squared, then the bit remaining must be the kinetic. So total energy isn't going to change, but in the middle it's just got two different forms, which are half mv squared plus 1/2 k x squared. So that was it. That was the hard part, figuring out our little equation. After that, it's just algebra. Hopefully you got the point. Total energy when it starts is going to be the same when it's in the middle. It's just changed forms. So we just had to figure out what that was. So let's do our algebra. Let's hope we don't stuff up. mgd plus 1/2 times x squared minus 2xg plus d squared equals 1/2 mv squared plus 1/2 kx squared. Alright, so let's just work through this. mgd plus 1/2 x squared, half minus xd plus half d squared equals 1/2 mv squared plus 1/2 kx squared. Have I left something off here? Yeah, I have. The k. The k goes at the start. So we'll put that k in. No problem. Kd squared, kxd, put that k there, put that k there. And let's see, so we've got plus kx squared there, we can cancel that one, we can cancel that one, and we're down to mgd minus kxd plus kd squared over 2 equals mv squared over 2. Getting closer here. We're going to have to obviously do some substitutions with the k's, and that should hopefully sort everything out. We'll be able to get rid of the m's. mgd minus k, which is mg over x, mg over x, xd plus mg over x, d squared, and let's not forget the d, equals mv squared over 2. Here we go, we can get rid of the m's now, lucky us. And we can also get rid of the x's on that one. And what are we left with? We're left with gd minus gd, that's nice, that one's gone, plus gd squared over 2x, gd squared over 2x equals v squared over 2. Oh, we can get rid of the 2's. Look, we got it. V equals the square root of g d squared over x. Also, sorry, v equals d times the square root of g over x. And we're done. A little bit trickier, but not really.